Hello everyone, in this video I'll be explaining you the problem maximum cost permutation, and it was asked in Educational Codeforces Round 182 for division 2. So let's read out the problem. Recall that a permutation of length n is a sequence of length n such that each integer from 1 to n appears in it exactly once. So don't worry, this line I'll be telling you even if you don't know. So let's define the cost of a permutation as the minimum length of its contiguous subsegment, possibly empty, that needs to be sorted so that the entire permutation becomes sorted in ascending order. So this statement, whatever they're saying, so we need to do it only once. So they have not specifically told you have to do it only once, but this statement says that you are given an integer array p. Don't worry, I'll be telling you on the board like what I was telling you, only once you have to do. So you are given an integer array p consisting of integers from 0 to n. Okay, so permutation will always start from 1 to n, but they have given from 0 to n, which means some of the elements are missing. So where no positive strictly greater than 0 integer appears more than once, you should replace zeros with the integers so that the array becomes a permutation. Your task is to calculate the maximum possible cost of the resulting permutation. Got it. So the input they have given integer t denoting number of test cases, and for every test case we have a single integer n denoting size of the array, and in the next line we have p1 p2 up till pn, and this pi will start from 0 till n. And so, and also they said since it is a permutation, so the positive numbers whatever we have except 0, because 0 is not a positive integer. So positive integer whatever we have, that is only once, there is no duplicate. So this line will make sense, don't worry, I'll be telling you. So first test case what we have is 10405. So length of the array is 5, and this array they have given us this thing. So let me tell you what they're saying is, whenever they give n as length of the permutation, so permutation array will have elements, if the length of the array is n, so it will have elements from 1 to n, and since array length is n and you're starting with 1 till n, so it is obvious that in the array you will have 1 2 3 up till n, and no elements will be repeated 2 times, and there will be no missing elements also, meaning let's say n is 4. So your permutation array will have element 1 2 3 4 only. You may have in any arrangement. This is also valid because your array length is 4 and you have elements from 1 to 4, and all are appearing only one times, like 1 2 3 4, and there is no duplicate also, there is no missing also. Let's say this is permutation, this is permutation. Now let's say you have taken 1 2 2 4, so array length is 4, but in this case if you see the elements 3 is missing, and instead of that 2 has appeared twice, so this is not a permutation. Now we can take 1 2 4 5. If you do that, the length is like 4, but you should have element like 1 2 3 4 only. 3 is missing and 5 has appeared, so this is also not a permutation. So I think that the definition of permutation is clear, and once it is clear, now you will understand. So what they're saying is, you have an array of length 5, and whatever like pi element you have, and if it is greater than 0, which is positive, it will be occurring only once, occurs once, which means it is unique. Like one, if you see, it has not occurred 2 times or 3 times, more than 1 time it has not occurred. Same with 4 and 5. So this will be considered as one of the permutation, and in the question what they've said is, you need to fill the values which are from 1 to 5 only, 1 to n only. So let's say I'll fill here as 3. Now if you do this, and finally they are asking you to sort the array. So this is a sorted array. So if you happen to see, this part is not sorted. So when you sort this part, the length of this part is 3, and the cost of the operation will be 3 only, and they are asking us to maximize the operation. So if you try to put one in this position as 2, then we have 4, 3 and 5, right? So here these are sorted only, this is also sorted, only this part is not sorted. So in this the cost of operation is 2, so they are asking us to maximize the cost of operation. So why can't you take this? And whenever you do operation, right, you'll be doing only once. It's not like let's say you have chosen this 1 3 4 2 5. So in this case, uh, in order to maximize the cost, you will take this as one of the swap. So you'll be doing 1 4 3 2 5. Then you'll be taking this as swap, like 1 4 2 3 5. Then you will be taking these two, like you will be doing multiple swaps, and the operations cost will be 2 2 2, but you can't do multiple swaps, you will have to do only one. In the question they have not mentioned specifically, but the solution they have designed in that way only, so that you will have to take the longest sub array in the permutation array in such a way that you will do you will have to do the swap once, so that we will get the maximum cost. So this is giving you maximum, so this is one of the valid array. So now now the question comes, how do you fill this 3 and 2? But before that, let me ask you one more thing. You have 1 3 4 2 5. So whenever you saw that, right, so 1 is in its correct position, 5 is also in its correct position. So in order to maximize this swap, you are taking the elements which are not in its correct position. Even if this array had something like this 1 2 4 5, so if you see, you can't take these 3 elements and swap. If you do that, so I mean if you do sort in this, since 4 is already sorted, right, so you can't do that. So only 2 operations you will be doing. So what do I mean by this is that, so you need to check whichever elements are in its correct position from left side and from the right side. Even if some of the elements, let's say 1 3 4 2 and then 5 we have, right? So yeah, this is a 5 length array, and if you see, this is at its correct position, this is also at its correct position, and this is also at as its correct position in the final sorted array. As you can see, only these two is not at its correct position, but you will have to take this subarray only. You will have to take this subarray only in order to swap this. So if you are taking subarray, so definitely even if the element is ordered, that will also be considered in your length of the subarray. So if you try to think of, which means it is kind of a problem wherein you have array, you have, let's say, this array which is sorted, and you have some portion of the array in between which is not sorted, some portion of the array in between which is not sorted. So from the left you will have to find that point from which the array element is not sorted. From the right you will have to find the point till which the elements are not sorted in its correct position. In this case, if you see, the left L is one of the index, let's say, which is keeping track of from left side which is element with in its in its not correct position. So this is not in its correct position. From the right, if you see, this is R, which is not in its correct position. So once you find that, your answer will be, basically cost will be R minus L plus 1. That is going to be your answer. Right? So once you have all the elements in your array, so you are going to do this operation. Basically find the element which is first element which is not in its correct position from the left and from the right, and the whatever length is length you have, that is going to be your cost. But now your array element is not given in that way, it has gone one more level deep. So they may give like whatever I've said just now, they may give as one of the problem wherein that will come as easy problem, but this is one more level you will have to find. So Now what we need to do is we need to fill the zeros. So in order to fill the zeros, since you want to maximize your cost, so you will try to fill the elements in such a way that the element is not in its correct position, because we want to maximize the cost. So if that is not in its correct position, so the correct element that here will be like 2, and here is going to be 4, but since we don't have that 4, let's say 3. So what you need to do is you need to place the elements from the left hand side, which means what I'm trying to say is that you have one, the next element whatever is there, that should be placed from left side only, right? It should be placed from left side. So if you place element 2 at this position, so it is going to be at its correct position and your cost will be reduced. So instead of that, we need to insert the next element from the right hand side, so that it is not in its correct position, and you'll get the maximum uh, subarray size, so that your cost will be maximum. So from like this elements whatever we have, that we are going to keep in a set, and we'll be checking, we'll take one num variable which is going to start from 1, and we will check from the right hand side, we'll go and we'll check if you find the 0, and you want to place this num in this 0. But before that you need to check in set. This set will contain whatever elements that is already present in P. So you'll check num is equal to 1 is there in this array or not, which is there, but you will not be running throughout loop, right? You want that in constant time, so we will be storing in a set. So 1 is there, so you will increase the next element to 2, and 2 is not there, so you will remove this and you will put 2 at this position. Now you will move forward, and you will come at this position where you have 0. Now since 2 is done, so you will increase one more variable. I mean 2 is already done, so you will be moving to ahead. So you will check if 3 is there in the array or not. It is not there, but how can you check in constant time? You will be checking the set. It is not there, so you will be inserting 3. So once you do that, you have got the one of the permutation, and now from the left hand side you need to check the position wherein the element is not at its correct position. From the right hand also you need to check. This is L, this is R. Now your cost is going to be R minus L plus 1, which is like 1 2 3, or 0 also you can take. R is 3, L is 1 plus 1, so this is going to be 3. So I think from one problem only you guys understood how we are going to solve this. So I can take one more example as well. We have 0 0 0 all the elements. Okay, let me take one more example for better understanding. So you have a P array as 0 0 0, and is 3. So okay, now you will be checking what all elements are there. We don't have any elements, so from the right hand side you are going to insert the elements. Your num will be 1 and your set is empty, so you don't have any you don't have 1, so you will be inserting 1. You are now at this position, so you will be inserting 2. You are now at this position, you will be inserting 3. Like every time you will be moving and you will be inserting. And the first element from the left hand side which is not at its correct position is this. From the right hand side it is this. So once you have got that, so your cost is going to be R, which is R is 2, L is 0 plus 1, and this is going to be 3, right? So this is the thing. I think you guys understood. Now one more example let me take, where n is 4. Your P is going to be, let's say, 1 2 3 and 0. Now okay, now you need to, as you know, like first you need to fill the element wherever you have 0. So your num will be starting with 1. In the set we have 1 2 3. So you are at this position, you will be checking if 1 is there or not. 1 is there, so you will be moving to 2. 2 is also there, so you will moving to 3. 3 is also there in the set, so you will moving to 4. 4 is not there in the set, which means it is not there in the array, so you will be inserting 4, and you have inserted all the elements. Once you have inserted all the elements, from the left hand side we'll be checking the mismatch position, like in the sorted, after you sort the p, it is going to be 1 2 3 4 only, but you will be checking in first position do we have one element which is there, in the second it is there, in the third position 3 is there, in the fourth position 4 is there. So in this case your L will not be pointing to anything. So once L is not pointing to anything, which means you don't need to do any sort. So in that case your cost is going to be 0. Now I think you guys understood. So let's solve it. Last example, so you can check where you have 0 2 3, so you can place 1 here this position. So 1, since it is already sorted in its position, and 2 3 is not sorted, so 2 is going to be your cost. We have here, I've solved it. So what I'm going to do is that we'll take inputs. We have integer t denoting number of test cases, so I've taken care of this position, and for every test case we have integer n, right? And we have n elements in the form of p1 p2 pn, so we'll be taking those elements input, and let's take the inputs. So we have taken the input. Now, so before, when we are taking input, right, so we need to keep track of the element as well in an unordered set. We need to first check if that element is not 0. If p of I is greater than 0, then we are going to insert in that set, which means the non-zero elements of the array are kept in unordered set in order to retrieve in a constant time. So now you will take integer num, which will start from 1, as I said, and you will move from right hand side, and you will move from right hand side. You will have to check what you need to check is if this p of I is equals to 0, which means the current element in the array is to be filled with the one of the number values. So you'll have to check while this set, let me call this at ht, that will make more sense. So that st dot find of num, if it is not equals to st dot end, which means in that set you have that element, so you will increase the element. So whichever element you have got, so that, I mean, which is not present in the set, which means that is the least number of element you will be inserting from the right hand side in order to maximize the operation. So you will be inserting, and then you will be going to the next number. So like once you have done that, now you need to take L, like basically that will be int maximum. I'll be telling you why I'm taking this. So I'll be checking here if p of I, whatever element is there at the array, like the at first position you should have 1, at second position you should have 2, which is like in a sorted array. So you will be checking if p of I not equals to I plus 1. Why I'm taking I plus 1? Because your I starts from 0. So like in the permutation you don't have 0 element, you will start from 1. So I plus 1 means which in the first element you have element 1 only, in the second element you have element 2 only. So whenever you have found the mismatch, right, I was telling you to find from the left hand side, right hand side, but I'll be doing in the from left hand side only. From the left hand side I'll be moving. If I find the first mismatch, so that is going to be stored in your L. So your L will be minimum of L comma I. Like once you have found the mismatch, even if you find later mismatch, your first mismatch will be at L, I mean the earlier only. So I'm taking that's my minimum. And your R is going to be R, I mean max of R comma I. Why I'm taking max of R? Because you're traveling from left to right only. You have found the first mismatch, then you are moving, you have found again mismatch, that you will be storing in right, which means you are saying okay, this is the last mismatch I've got. But even in the later stage, if you find again mismatch, then you'll saying you'll be increasing R2 max of R comma I, which means you'll be saying okay, this is now my uh, right hand side max mismatch. So again it will be moving. So that is the thing. So once you are done with these things, you have found the left max and right max, I mean left hand side right hand side index where the elements are mismatched. So in the case wherein your element are already sorted, third case I was discussing 1 2 3 and then 0 was there. So in that case when you place 4 at that position, because that is only the valid, I mean element to be inserted at that position. So in that case your L, your this if condition will not go into, because all the elements are in its correct position, so your L and R remains same. So if that is the case, so in that case you will not be doing any operation, your cost will be 0. So you need to check if L is equals to int max, then you need to output 0. Else if your L and element L and R has some values, so that is going to be R minus L plus 1, size of the basically subarray. So I think you guys understood this. Let me try to submit. So it is maximum cost permutation. So it got accepted. Yeah, in this way you could have easily solved the problem. I think this is clear, right? Basically you are finding from left to right, but I was telling on about from left to right you will have to find the mismatch. But one way you can do is you can travel in one direction and you can find first mismatch which is stored in L, and then even if you find later mismatch, your L will be the previous mismatch only, but your R mismatch will be keep increasing, which means the right hand side mismatch will be keep increasing, and you will have the answer. When your L is like int max only, initial value only, which means you did not find any mismatch, all elements are sorted. So in that case you have to display 0, or else you will have to display the size of the mismatch portion. So yeah, thank you guys for watching the video.